Ever feel like the world of tech, especially, data, is just moving at warp speed? Keeping up with all the latest architectural shifts can honestly feel like a full-time job itself. Well, you're definitely in the right place today. We're taking a deep dive into something absolutely foundational, yet it's constantly evolving. Data pipelines. We're going beyond ETL to explore the incredible journey of these architectures. Right from their humble beginnings to, well, the cutting edge. Our mission for this deep dive, it's really to pull out the most important nuggets of knowledge from our research, articles, industry reports, our own notes, so you can quickly grasp what's truly important and maybe apply it. Whether you're prepping for a big meeting, trying to catch up on a new field, or maybe you just like insanely curious. We're aiming for those aha moments, but without making you feel like you're drowning in information overload.
Yeah, and what's truly fascinating here, I think, is that this isn't just about understanding technical jargon. It's really about getting to the why behind each evolution. What specific problem was it designed to solve, and how knowing these differences can fundamentally clarify your decision-making in today's, well, very complex data landscape. It's kind of a journey that shows how innovation really responds to need.
Okay, let's unpack this journey then, starting right at the beginning, the origin story. When we talk about data movement, the first thing many people think of is ETL. So, what exactly is a traditional ETL tool, and what were its core design principles?
Right. So at its heart, an ETL tool is basically a software application designed to move data. Pretty simple, right?
Mm.
It extracts data from various sources, databases, files, APIs, whatever, transforms it into a usable format, and then loads it into a target system. Usually that targets a data warehouse or maybe another database.
Hmm.
And we call them traditional because, well, they were built for a specific kind of workflow. Think highly structured, predefined steps,
Yeah.
and almost always operating in a batch-oriented environment, like dedicated workhorses for moving big chunks of data, typically overnight or on a fixed schedule.
Okay, so inherently batch first. Our research actually highlighted that they focus solely on extract, transform, and load as predefined steps in a batch-oriented environment. And it said they're designed for structured workflows, but they don't natively handle real-time, flexible, or distributed processing. So basically, minimal real-time capabilities then.
Exactly. Minimal is the word. Their primary focus was squarely on those nightly or hourly loads. And that just made them less adaptable to real-time architectures. The latency you'd typically be looking at was in the range of minutes to hours. We're talking about established tools, like Informatica, Talend, maybe Microsoft's SSIS. Powerful for their time, absolutely, but inherently limited by that batch-first design, especially for a world that now demands instant insights.
Right. So businesses found themselves kind of stuck, needing insights now for critical decisions, but having to wait for those overnight reports. That must have created a significant bottleneck as data needs, evolved.
Oh, absolutely, it
Okay.
did. I mean, imagine a retail company needing to react to a sudden sales surge, right?
Yeah.
Or maybe a fraud detection system that only updates once a day. Pretty useless, wouldn't you
Yeah.
say? As businesses started needing faster insights, not just for looking back, but for immediate operational decisions, these batch systems just couldn't keep up. The need for speed became, well, paramount.
Which brings us neatly to our first big leap, modern scripting ETL pipelines. So, if traditional tools hit a wall, what was the first major breakthrough to push past those limitations?
This was a pretty fundamental shift. I mean, these aren't just a slight evolution of ETL. Our sources call them scalable, real-time data pipelines that can ingest, transform, stream, and integrate with modern storage systems.
Hmm.
The key difference, they truly combine batch and streaming in the same ecosystem. That's huge. And critically, they're code-based. You're talking PySpark, maybe Airflow for the orchestration piece, Kafka for messaging, platforms like Databricks. It's not the older GUI-driven tools. And this code-driven nature, well, it unlocks immense flexibility.
Okay, code-driven, supporting batch, microbatch, streaming, and event-driven modes, and designed to scale horizontally on distributed systems. That's a massive shift from being locked into, say, a single vendor's architecture. Can you clarify microbatch a bit more? What does that mean in this context?
Yeah, good question. Microbatch is kind of a hybrid approach, you see. Instead of processing data one event at a time, like true streaming or waiting for that huge overnight batch, it processes small batches of data, but very frequently, maybe every 2 seconds, or perhaps every minute. It's a way to get near real-time performance without necessarily jumping into the full complexity of event-by-event streaming. Especially useful if your downstream systems aren't quite ready for continuous processing. And this shift, Well, it means latency drops significantly. We're talking milliseconds to seconds typically,
Yeah.
which makes them suitable for those critical use cases traditional ETL just couldn't handle. Fraud detection, live dashboards, IoT processing, and even ML model serving. This is where data really starts becoming actionable in the moment.
Interesting. So it seems like, just as one problem gets solved, getting data faster and more flexibly, a new set of challenges kind of emerges. We've mastered flexible, fast data to some extent. But the evolution didn't just stop there, did it? What were the driving forces behind the sort of next wave of evolution?
No, definitely not. It kept going. Our research points to several key trends that really define this continued evolution, and they often happen concurrently. First, there's a really strong move from batch to real time. It feels like real-time analytics is becoming the default expectation now. Then there's this fascinating shift from code to declarative. You see more focus on frameworks like dbt, which lets teams define transformations using SQL, much more accessible, easier to version control. We're also seeing a move from centralization to decentralization, things like data mesh and domain ownership, where data responsibilities get spread out across the business domains. And then there's a big trend towards operationalization, MLOps, feature stores, making sure machine learning models are robust and features are consistent between training and serving, real engineering rigor. And finally, a clear move to cloud-native and serverless platforms. Fully managed, elastic. The cloud providers handle a lot of the complexity.
Okay, let's zoom in on a few of those, starting with that really intense need for immediate action. What exactly does data streaming and event-driven architectures mean for those always-on pipelines and near real-time or sub-second latency requirements?
This is where data becomes like the literal heartbeat of your business operations.
Yeah.
These are genuinely always-on continuous pipelines that process events in near real-time or real-time. No waiting around. Their latency is incredibly low. We're talking milliseconds to seconds. And it's driven by an event-based trigger mechanism. So what that means is they process each event or message essentially as it arrives without waiting to batch things up. Think of tools like Apache Kafka as the backbone, for streaming the events, or maybe Spark Structured Streaming, Apache Flink for actually processing them.
Wow, milliseconds to seconds. That's a massive leap in responsiveness. Our sources also highlight their extreme scalability, handling millions of events per second. That's obviously crucial for things like acting on fraud the instant it happens, or personalized recommendations updating the second a user clicks something. It's like the difference between looking in the rearview mirror versus actually steering the car in real time.
Exactly. That's a great analogy.
Yeah.
And when you compare them to the modern scripting pipelines we just talked about, modern scripting is excellent for those batch-heavy orchestrated workflows, and it can support streaming extensions like microbatching. That's true. But these event-driven architectures, they are pretty much mandatory for truly real-time use cases, where every single event has to be processed immediately with minimal delay. They're built for millisecond-level SLAs, whereas modern scripting pipelines often handle, say, minute-to-hour level SLAs very effectively. Different tools for different jobs.
Fascinating. Okay, so if we've kind of mastered the art of fast data, what about simplifying how we manage it all, keeping it reliable? That seems to be where something like the Data Lakehouse architecture comes in. This concept seems to be about merging data lakes, great for flexible storage, with data warehouses, which are known for structured queries and reliability. How does that merger actually work?
Yeah, the lakehouse is a really interesting concept. It's pitched as a unified architecture combining the flexibility of data lakes with the reliability and transactional power of data warehouses. And crucially, it provides full AC transactions. That's atomicity, consistency, isolation, durability, the fundamental database guarantees you need for reliable transactions. And it offers these ACD guarantees across both batch and streaming ingestion. That's the key. So you get the trustworthiness, the data quality of warehouse, but within the flexible, often more cost-effective storage of a data lake. Plus, it aims to offer unified SQL-based queries for both batch and real-time data. One place to query everything.
Right. And what are the key technologies making this happen? Beyond Databricks, I know you mentioned them, but I've seen Delta Lake, Apache Iceberg, Hudi mentioned a lot too.
Absolutely. Those are the primary open source table formats, let's call them, that bring those ACD properties and other warehouse-like features directly to data lake storage. They're fundamental to the lakehouse concept. Now, when we connect this back to the bigger picture for the listener, why is having a unified BI and ML data science ad hoc analytics use case so powerful for an organization?
Well, I guess it means you're not siloed anymore, right? You can use the same governed, reliable data for your traditional business intelligence dashboards, and for cutting-edge machine learning model training, and for exploratory data science, all within one consistent environment. It must streamline the whole data stack.
Precisely. You hit the nail on the head. The Data Lakehouse is really aiming to be the best choice for unified storage and querying with ASIC guarantees that can handle batch, streaming, structured, and unstructured data all in one architecture. It offers, or promises, unparalleled flexibility for diverse data workloads while maintaining that critical data integrity.
Okay, now for many people, especially those maybe not deep in the coding weeds, this next evolution sounds like, well, pure magic. Serverless and no-code data pipelines. What's the promise here? What does this mean for teams who aren't necessarily data engineering experts?
Yeah, the promise is definitely simplicity and speed. These are essentially fully managed, cloud-native, often visual pipelines with minimal coding and zero infrastructure management. That's the dream, right?
Yeah.
The primary focus is really on simplified pipeline building, making it possible for rapid deployment, and enabling citizen data engineering without needing deep coding skills. Serverless here means you don't touch servers, you don't provision them, you don't manage them, you don't scale them. The cloud provider handles all that underlying infrastructure automatically, and typically you pay per use, only for what you consume.
Okay, so fully auto-scaled by the cloud provider, that pay-per-use model, and very low complexity because they're designed for fast, easy deployment, often with drag-and-drop interfaces. You mentioned AWS Glue Studio or Azure Data Factory in its UI mode earlier, those kinds of visual tools. That sounds incredibly appealing for quick integrations or simpler tasks.
They definitely simplify things dramatically for certain use cases. They're often the best fit for fast prototyping, citizen data engineering, standard SaaS to cloud integrations, basic transformations, and maybe ad hoc data movements. If we compare this back to modern scripting again, serverless and no-code really prioritize simplicity, speed, and kind of democratizing data engineering tasks, empowering a broader range of users to build pipelines. Modern scripting, on the other hand, gives you maximum flexibility, maximum control, but it absolutely requires hands-on coding and orchestration skills. So it's often a trade-off. Maximum control versus maximum ease and speed for certain tasks.
This definitely raises the big question. With all these powerful options, scripting, streaming, lakehouse, serverless, no-code, how do you actually choose? How do you navigate this landscape effectively?
That really is the core challenge, isn't it? But we can simplify it a bit with, let's call it a decision-making summary based on the key distinctions we've discussed. For your traditional batch ETL needs large data volumes, processed periodically. Modern scripting pipelines are often still the best fit because of their flexibility and control over complex logic. But if you need real-time processing with millisecond-level latency, then data streaming and event-driven architectures are clearly the best fit. The others are either limited or, frankly, not ideal for that. If your primary goal is unified BI and ML on a single reliable platform handling diverse data, a data lakehouse is likely your best fit. And for rapid prototyping and citizen data engineering, or when zero infrastructure management is absolutely paramount, then serverless and no-code pipelines really shine as the best fit. It truly comes down to deeply understanding your specific requirements: latency, scale, complexity, team skills, budget.
Okay, let's try and ground this in a really concrete, real-world scenario. Our sources talk quite a bit about integrating Salesforce data. What's a modern, efficient way to handle that, perhaps using one of these approaches we've just discussed?
Right. Salesforce is a classic example. A tool like Fivetran is actually an excellent example here. It really embodies that fully managed, low-code, no-code approach we talked about. And it's a very popular choice for connecting Salesforce specifically to modern data platforms like Snowflake, BigQuery, Redshift, or even a Databricks Lakehouse. It's important to note Fivetran is typically an ELT tool: extract, load, then transform, which is a bit different from traditional ETL, where transformation often happened before loading.
Okay, ELT. So for our listener, when would a tool like Fivetran be an absolute game changer for integrating Salesforce data? What are the sweet spots?
Well, it's ideal when you need fast, reliable Salesforce syncs into something like Snowflake or a Lakehouse, and you want to do it without writing or managing custom code. That's its core value prop. Fivetran provides these pre-built, production-grade Salesforce connectors. They handle things like incremental sync using change data capture or CDC. Basically, it only replicates the changes in your Salesforce data after the initial load, which is much more efficient and saves on API calls. It also provides automatic schema management. So if you add a field in Salesforce, Fivetran usually just handles that change automatically without breaking your pipeline. Huge time saver. Plus, it's fully managed, No infrastructure for you to worry about. And it offers near real-time replication, typically syncing every 5 to 15 minutes, which is often plenty fast enough for analytics use cases.
Okay, that sounds pretty compelling for many scenarios. But where might you hit its limits? When would you maybe need to consider a different approach for Salesforce data?
Good question. If you genuinely need true millisecond-level real-time streaming, maybe for an instantaneous operational decision directly triggered by a Salesforce event, Fivetran sync intervals, even at 5 minutes, might not be fast enough. Also, if you have very specific complex transformations that absolutely must happen during the ingestion process before the data even lands in your warehouse, Fivetran, being ELT, isn't designed for that. You typically transform the data after it lands using tools like dbt. And lastly, cost. While it saves a ton on engineering time and maintenance, depending on your data volume, a fully managed solution like Fivetran might have higher direct costs compared to building something custom with open source tools if you have the team to support that. For those true sub-second real-time needs from Salesforce, you might look at something more like Kafka Connect, using Salesforce's own change data capture features directly.
Got it. There's a lot of really powerful information, a lot of options. So how does someone actually apply all this knowledge when they're starting a new data project? What's a practical way to navigate these choices?
Yeah, it can feel overwhelming. But we can use something like a project delivery checklist as a practical guide. Think of it in stages. First stage, initial assessment. This is where you really define your latency requirements. Is it batch, near real-time, true real-time? You also need to honestly identify your team's skill levels. What are they comfortable with? Determine your target data sources and destinations. Evaluate the project budget. Can you afford managed services, or do you need to build custom? And of course, confirm all the security and governance requirements up front.
Okay, so that initial assessment then directly feeds into the next stage, architecture selection, correct?
Exactly. Based on that assessment, you choose the architecture that fits best. Maybe it's modern scripting pipelines if you need that custom logic and complex transformations. Perhaps data streaming architectures if low latency event processing is the absolute priority. Could be no-code pipelines if rapid delivery or empowering citizen data engineers is the main goal. Or a data lakehouse if that unified storage with asset guarantees is essential. And honestly, quite often, it ends up being a hybrid architecture where maybe batch and real-time ingestion need to coexist effectively.
Right, makes sense. Then you move into actually choosing the tool evaluation.
Precisely. Here, you need to validate the availability of pre-built connectors, like we discussed with Fivetran for Salesforce, for your key sources. Saves a lot of effort. You have to assess cost efficiency, remembering to factor in not just the license or usage cost, but also the savings on maintenance and engineering time. Confirm ease of maintenance is huge. How easy is it to monitor, debug, and update? And critically, evaluate fault tolerance, scalability, and schema evolution support. You need to ensure the tool can handle failures gracefully, scale as your data grows, and adapt to changing source schemas without constant manual intervention.
Okay, and then the final stages seem to be about getting ready to build and making sure it lasts. Implementation readiness and governance and handover.
That's right. In implementation readiness, you finalize your orchestration strategy. How will these pipelines be scheduled and monitored? Using tools like Airflow, or maybe cloud-native schedulers like AWS Step Functions or Azure Logic Apps. You need to confirm integration with your cloud-native deployment tools, things like Terraform or CI/CD processes. You absolutely must design automated testing for your pipelines, data quality checks, integration tests, and establish operational dashboards and failure alerting so you know immediately if something goes wrong. Then finally, for governance and handover, you need to implement data lineage tracking so you understand where data comes from and how it's transformed. You have to clearly document pipeline ownership. Who is responsible for what? If you're using no-code or self-service tools, you need to prepare user training. And always, always review the long-term scalability to make sure the solution you built today will still work tomorrow.
Wow. Okay, so that checklist provides a really structured, practical way to navigate what can feel like an incredibly complex, but obviously crucial landscape. What an incredible journey we've taken today, really. We started with the basics of traditional batch ETL, which feels like ancient history now almost, then moved into the power and the flexibility of modern scripting pipelines. Then we explored the essential real-time capabilities of data streaming and event-driven architecture, so critical now. The unified strength, and importantly, the reliability of lakehouse architectures. And finally, that transformative simplicity offered by serverless and no-code solutions. It's quite a spectrum.
It really is. Yeah. And I think the core insight, if you boil it down, is clear. Each of these architectures offers unique strengths. There's no single best one for everything.
Scripting pipelines give you that ultimate flexibility and control. Streaming delivers immediate, real-time responsiveness. And no-code solutions genuinely democratize data access, opening it up. The key, really, is knowing which tool fits which job. And that decision has to be based on those crucial factors. Latency requirements, orchestration needs, scalability, the complexity you're willing and able to manage, your team's skills. It's all about making informed, strategic decisions for your specific context.
Absolutely. And understanding this evolution, it isn't just about learning technical terms, is it? It's really about empowering you, the listener, to make smarter choices. Choices that can truly move your organization forward in what's becoming an increasingly data-driven world.
Which, brings up an interesting question for the future, maybe something to ponder. How might this continued trend towards something like data fabric, this idea of integrating automated discovery and unified access across hybrid environments, how might that fundamentally reshape the future roles of both data engineers and citizen data scientists? What new skills do you think will be most valuable in that kind of evolving landscape?
That is a powerful thought to leave you with. Definitely something to chew on as you navigate your own data journey. Thank you so much for joining us on this deep dive today.